Thank you, Ban, and thank you to the Broadband Forum for this opportunity. My name is Rodger Lutaaya. I work in the Network Technology Department of Openreach Limited. And I'd like to take the opportunity to just talk to you about a few things regarding future-proofing access technologies or access networks. I'll start off with an introduction about Openreach, and I do this intentionally because it's useful for the context for what we are going to talk about. And Openreach is a wholesale access network company. It's based in the UK. It's an independent company that's wholly owned by BT Group. And Openreach owns several access networks. As an access network based in the United Kingdom, providing connectivity across the United Kingdom, from Scotland to Wales to England, connecting homes and businesses to the retail provider of their choice. Openreach is a very big company, about 37,000 employees. 27,000 of those are field engineers in the field. And we are busy working on fibering the whole of the UK. That's the key thing that we're working on. And who are our customers? As a wholesaler, we're not dealing with the end customer. However, the retail service providers, we call them communication providers, those are our customers. And there's over 650,000 of them. They do range from the very big ones to smaller ones, to some which are regional based. But what Openreach does is to present our network to all of them in a fair manner at an equivalent level. We're very known for our retail broadband services, but actually, Openreach network is far more than broadband. On the bottom right of this slide, I'm showing the retail services that we do support, whether it's fiber to the premises or fiber to the home, fiber to the cabinet using VDSL and GFAS technologies. And we've been successful of that. Our FTTC platform grew to 16 million customers, and we're building our FTTP platform as well. But we do actually have other access products that we provide, especially to businesses. EAD is Ethernet Access Direct. So this is us providing point-to-point dedicated Ethernet services to businesses. You tell us where you want it, and we will build it. That's very useful for businesses, government, libraries, schools, everyone that's looking for dedicated connectivity. We can provide it. Our retail service providers are not present at all of our 1,000 points of presences or exchanges where we serve the fiber to the premises or fiber to the home broadband. So sometimes they will take up these high bandwidth products from us, and we will backhaul their traffic to wherever they want us to take it, whether it's in a data center somewhere or anywhere else. Optical spectrum access, again, very high bandwidth. Some of these communication providers are regional based, and they will ask us to aggregate all their traffic and move it down to London or somewhere where they connect, and we provide those technologies. And now I want to talk about FTTP evolution, specifically the PON technology evolution. I don't believe what's on this slide will be any surprise to anybody, where we see XPON technologies going from standardization to deployment over several years. And we can see this divided up in three categories. The global volumes today, the emerging technologies, and even technologies which are currently at university research. So we've got colleagues or partnerships in the universities already looking at 100 gig and 200 gig PON and what that will look like. With the emerging technologies, 25 gig, 50 gig, These are already standardized PON technologies. And in fact, we've taken part of some trials with our partners in the UK to show what these could do, providing what the future of PON technologies would look like. But most of the global volume today is actually in GPON and XGS-PON. GPON, very highly deployed, providing lots of connectivity, and XGS-PON gathering momentum. And today, what I want to talk about is, as we look at these, how do we future-proof our networks to be ready to provide the connectivity, the bandwidth, the services that the end users and our customers are going to need? We've talked about FTTP, or fiber to the home. And I'll provide further context here by just telling you about our journey with fiber to the premises. Openreach has already built 17 million customers out of the UK who can connect to our fiber to the home network. We've managed to connect about 7 million of those, and we are committed to build another 4 to 5 million every year. We've got funding to do 25 million by the end of December 2026, and we'd like to get to 30 million at some point. We've become pretty good at this. We're doing about 70,000 a week. In my role as a principal architect, talking to the product managers and the executive committee, the thing they always talk to you about is, how do we know we are doing the right thing? How do we know we are making the right investment? That build that I've just mentioned is 12 billion pounds worth of investment by the BT Group in Openreach Limited to fibre up the UK. How do you make sure that that investment is future-proofed? And one of the things that we've been doing for over a decade now is looking at our network by collecting the performance monitoring statistics and looking at that capacity of the FTTP network that we've built. It's all based on GPON today, and we know the limitations as I showed them earlier on. And just trying to work out, do we have the capacity to be able to provide our customers with the connectivity that they need for now and for the future? How do we balance that with making sure that we guide the business with what the right investment is to do? And what this is showing here is that, having looked at that, for several years, we could see that the growth, or what we call the compound annual growth rate, was at about 20%, steadily at that. And as it has saturated, it's now come down to about 5 to 8%. And we do look at things like, what's the meridian or the median peak average? So for every user, what do we tend to see? And at peak times, we're not seeing any more than 15 megabits per second. So we then do some extrapolation and say, where do we think we are going to be in a few years' time? By the end of this decade, where do we think we are going to be? And that's what that extrapolation is talking about there, to say that actually, with that in mind, we do not think that we're going to be any more than 24 megabits per second. And the graph on the left is basically showing that for a single PON, where we have got greater than 24 customers, and our split ratio is 1 to 32, we can see that only 1% of those PONs have got a saturation that's greater than 850 or 900 megabits per second. All of this to say that actually the GPON technology has still got lots of bandwidth to provide the connectivity that the customers need. But should we then do nothing about our network? We think the answer is no. We think we need to be setting ourselves up to provide the bandwidth of the future. And from those emerging technologies and the grown technologies that we're looking at, we're thinking about, where do we go next and how do we do it? And that's the crux of what I want to discuss today. So at Openreach, we're thinking about XGS-PON. We believe that that will provide us with the extra bandwidth to provide not only the needed growth in user connectivity, but also an opportunity for some of our business customers to take up FTTP best business products. So we started thinking about how can we do this in a manner that balances the two things that I'll keep repeating. What's the right investment to provide the right connectivity and the right services? We've looked at many options, but two that we have assessed. One is overlaying the network. So we've built a GPON best network, which I'm showing at the top there. So we've got GPON active electronics in our exchanges. We've connected them up to a coexistence filter, and we're providing GPON FTTP services as shown at the top by the two GPON ONTs. We thought about deploying XGS-PON capable OLTs in our exchanges and basically overlaying that through a coexistence filter onto our fiber network, and then providing XGS-PON ONTs to customers as a way of delivering XGS-PON best FTTP services. We then considered that against what we are calling combo. Combo is where we get new OLTs that are basically capable of supporting optics that have coexistence filters built in, so that we can deliver both XGS and GPON from the same headend. We've gone far to decide what we're going to do, and we've started doing it. We've decided to go with the combo. We've decided to take the investment into the combo capable headends, deploying them in our exchanges. But what we are actually doing is to deploy them in GPON mode because of that capacity that we showed earlier that's still capable. So we're doing that so that we can provide today's needs, but we are starting to future-proof our network, because later, as we get the business cases for XGS-PON, we can swap out the optics for XGS-PON optics, and we can start delivering XGS-PON best FTTP. We've not stopped there. What we've also launched is to launch greater than 1 gig products, best on GPON, but to basically go to the market and test what the appetite is for these higher speeds. And we're monitoring that to understand what the take-up is, what the drivers are, to help us prepare for when we should launch our XGS-PON products. We're also preparing our own trials for XGS-PON, but we're using this to fully understand what the market is looking at. So as we're doing this, we believe that we'll be in a position to react faster, quicker, as and when we need to deliver the XGS-PON services. Do we think that's enough? We don't believe that's going to be enough. So what else are we doing? We're looking at the network architecture and the network management to complement what I've just talked about. So fast onto network architecture. How do we build an architecture that provides the flexibility and the freedom, not just for scalability, but for us to react quicker to evolution and changes in the market, to new products and new devices becoming available? We've previously relied on chassis-based deployments, as you can see on the left-hand side here. We've been successful using these, but we've now moved and borrowed some, highly successful data center technology in leaf spine leaf, and we're using that to now deliver access broadband. We're calling it a physical disaggregation of the chassis, where the cards that we used to use to connect to our communication providers, we're calling them communication provider leaves. And we've got some spine aggregation switches in the middle. And then we have access leaves. And that's the flexibility that I would like to point out. It's giving us the flexibility to grow the cluster as and when we need to. So we can deploy it on day one based on the demand that we are expecting. And we can then grow it as we need to. But it's not just that. We are getting the opportunity to make this a multi-technology and a multi-product cluster. By multi-technology, I can have an access sleeve that's GPON. I can have an access sleeve that's combo. I can have an access sleeve that's actually only Ethernet. But why is this important? For our communication providers, on the left-hand side, they simply have a single point of connectivity into this cluster in order to serve the whole of that region. That connectivity takes time, takes money, and that's why this is important for them. And we're doing this, making sure that we can now increase how many homes can we serve. On the left-hand side, you can see that this was at 9,000 at maximum. On the right-hand side, we're talking about 50,000. We can now provide bigger communication ports to our customers at 100 gig, and they can serve a whole region through this single cluster. We obviously build up the resilience at all layers to make sure that it's sufficient. But we get the opportunity to basically swap out the right-hand side, which is the access sleeves, as and when we get better devices, without impacting the customer on the left-hand side. So this is an architecture that's now live in our network. We're using it, and we'll continue to build it in order to provide the services. It's an architecture that needs or has to be complemented with far better network management than what we have got today. And that's why I want to talk about what we are thinking about and doing when it comes to network management. Openreach is a volume business. I've talked about 16 million FTTC customers, now seated at around 7 million in FTTP, more than 300,000 business sockets. We are a volume business. We need to be able to provide unified control of all the network elements that we've got, and to provide provision of services, maintenance of services, and modification of services at a very high scale. And previously, what we've had with traditional element management systems was very inflexible, proprietary based on the interfaces north and south management systems. And those have exposed all the network complexity to our internal Openreach OSS systems or IT systems. That's one of the things that drives the long lead times and the cost. It's everything that my executive committee talks to me about not liking. Why does it take too long to introduce a product, Rodger? Why does it take too long to introduce a new service? It's because we've got to do the integration with the network complexity in mind. So what do we do about that? We're trying to move away from that onto modern software-defined networking-based management and control systems. These are systems that are providing an abstraction, hiding the network complexity away from the integration with the systems. And it's the reason we're actively engaging in the Broadband Forum and the standard organizations to try and standardize what the interfaces that are used to communicate north to our systems and south to the different network elements. Knowing full well that that will provide a single point of integration, we integrate once using models that are standardized and interfaces that are standardized, allowing us to provide a higher and quicker turn rate when we're introducing services or products. That still provides a lot of work to do. And what we're seeing there is that there is still an immaturity in some of the standards, and we continue to engage, and I encourage everybody to continue to engage to help us to close those gaps. And we continue to also participate to where we think this will end up and where it needs to end up. We believe that there is still a lot more autonomy to come when it comes to the management and control of a network. So on the right-hand side, I'm showing a future next generation SDN-based management and control layer with a lot of autonomy in it, allowing for autonomous decisions by that management and control layer, reacting to things that are going on in the network, and basically providing that without a lot of input from the operators. I'd like to reiterate what I've written at the top there. On the left-hand side, these are the business challenges that we face today. On the right-hand side, that's where we want to end up, where it's faster and cheaper to integrate, where it's quicker to introduce products. And we believe that this is going to play a role. The last thing I want to highlight here, the thing that I'm constantly being asked about is how do we improve the network assurance? How do we provide the best customer service to our customers? And I believe that by doing this, we will provide the hooks and the enablers to be able to monitor the network in real time, understanding what's going on at each and every single customer level in order to take the right decisions to fix the network quickly. So a telemetry-based network assurance, that's where we want to get to, collecting the right information, and that information could be whether services are up or down, why they're up or down. It could be to do with capacity management so that we can react. But the net effect or the net gain of where we want to end up is we would never be in a position where a customer contacts us about an issue on their service and we did not know yet. We want to know quickly. We want to react in the right way. And that reaction in the right way translates into pounds and pennies. Many a time we're sending out engineers across the UK who get to the problem or who get to the equipment that we think has got a problem, and we find out it's not the right engineer. He hasn't got the right skills or the right tools. We want to be able to collect the right information, identify where in the network the fault is, and send the right skilled engineer closest to the area, react quickly, and thereby providing the best customer experience. In conclusion then, I want to say that evolution, this is technological evolution, and transformation driven by user and business demands, those are going to remain constant when it comes to access technologies. But we all need to continue building the right building blocks. And why do we do that? Because we want to future-proof these networks to continue to provide the much needed connectivity and much relied on service that are people using to live their lives. And we're going to do this by transforming the network architecture. We will make it multi-technology. We will make it multi-product. We will make it multi-vendor. We will transform our network management to provide the autonomy, the abstraction, and the interoperability. And we will provide the network assurance, taking it from where we've been reactive to where it's proactive, preemptive, and even predictive. Thank you very much.
Thanks a lot, Rodger. Thanks for the presentation. It's spot on, and spot on the time too. The way we have set it up here is that after each presentation we have a quick Q&A. Are there any questions from the floor?
Since the beginning of the internet, what pressed for higher and higher speed were the applications and the content providers. I do remember 8-10 years ago defending the fiber to the home in many presentations. I talked about, not only me, a lot of people talked about super high definition television, ultra high definition television for the corporate world, 3D video conferencing, 3D television. And talking to content providers at that time, I asked, why do you don't start offering that thing to press for higher speed? They said, well, if we look to the whole population, there is so small percentage of population who have gigabit access. No? So after these 10 years, things changed, and even in countries and regions where we have close to 100% of fiber optic connectivity, I don't see those applications. Why do you think these content providers are shy offering this? Because these would press for higher speeds that what you mentioned, I think 24 megabit. Now this is the peak of the most of your customers. Thank you.
Thank you. Good question. I think the first thing we need to think about here is often you ask yourself what comes first. Do you build the network or do you build the applications? And I think we're getting to the point where, as you've mentioned there, those applications that we were anticipating that were going to demand the level of bandwidths that would not be supported on the lower technologies, they've not actually come to that fruition. We've found that ultra HD connectivity, it's not that people are not watching it, people are, but you don't actually find everyone doing the same thing at the same time. And so you get the applications being built, whether it's 8K television, whether it's other applications like live, some of the highest peak bandwidths that we see on our network is when you've got a Champions League final that Amazon Prime decides to broadcast or something like that. But they're all very intermittent in nature. It's different the user behavior has changed so much that we no longer see what we used to see, for example, with terrestrial TV, where everybody watched exactly the same thing at exactly the same time. So I don't think it's a lack of content providers not wanting to build the applications. I think the applications are slowly being built, but they're doing the same thing in tracking, making sure that it can be delivered end to end. And the network providers, we're gearing up for being able to support those applications when they appear.
Okay, thanks a lot. Okay, wonderful. Thanks a lot, Rodger. Excellent presentation again.